Okay, in example 2, like I've been saying, every situation is going to be different. We've got to establish as much of an understanding about what's going on here as we possibly can in terms of where is the particle, maybe where is the particle to begin with, what information have we been given? Are we being given a statement about velocity or displacement or acceleration? And yeah, just working out then what, like I said before, what's happening at initially when time is naught. And if we solve then for t, realise then, if we find that t is equal to 1 or 3 or whatever, then we've got now an understanding of what the particle's doing 1 second later or 3 seconds later, where it is, what the velocity of it is, what is there any acceleration on it, and really there's only those 4 things are going to happen. We want to know the time, we want to know its displacement at that time, or its velocity at that time, or its acceleration at that time. Now that's really if you can get an understanding for each situation of those 4 concepts, then I don't think you'll have any trouble with these questions. So, example 2. A particle's acceleration function is A is equal to 24t. So immediately we read that, we know it's different to the first example that I have included here, because in that example I think you were given the equation for its displacement, its velocity. So I note that. I would note that immediately, because I've got to be aware of what's being given in any one question, because it's not going to be the same from question to question. The information given is going to be different. So you can see there that I've done that. I've noted it by writing it down. It's sort of an acknowledgement that yes, I've realised that. And to be honest, if you've read that introduction to this question and you didn't realise that was something that you should have acknowledged and be aware of, then I would say that you're missing some really important information. It goes on to say, initially it is at the origin. And again, these are not words you can ignore. In that one word initially, you can see I've acknowledged when t is equal to 0. That comes from that one word initially. It is at the origin. Tells me about its location, its displacement. And I note that mathematically with the letter x, because that represents displacement. And the origin is 0. So I write this now. I've been able to interpret is at the origin. Moving with velocity -2. And again, minus 12. I write that. So what do I know? It's got an acceleration function. Initially, it's at the origin and it's going backwards. Its velocity is -12. So I'm expecting that if I was to draw my understanding of the situation from the beginning, I've got, this is 0 displacement, I've got the particles going in that direction, and this is t is equal to 0. So t is equal to 0, displacement's equal to 0, velocity, it's going in the negative direction, and it's got an acceleration, a function for its acceleration, which looks positive. That 24t is positive. That means although the particle is going in the negative direction, remember I said acceleration is a force, it has a positive force on it. So you might be thinking already, okay, so it's going down negative, but if it's just got a force that's in the positive direction on it, there's probably a point where it's going to stop. I don't know how far negative it will get, but it would stand to reason to think that the particle would eventually stop, and because it's got the positive force on it, then it will head back in the positive direction. Okay, let's see what does A ask? It says it tells you to integrate. Well, that's really nice. And like I said in the previous example, don't expect to always be told how mathematically told mathematically what you need to do. Just expect that sometimes all the instruction in part B might be is find the velocity function. So you may not get all of this, integrate, substitute the initial condition. You might just get asked to find the velocity function. So I'm finding the velocity. So I know that velocity, this is what I have to know. This is what I have to be able to bring to the solution, that velocity is the integral of acceleration. They didn't tell me that, but they gave me a fair hint told me I would be integrating. So my velocity function would be the integral of what my acceleration function is, 24t. So now I'm working mathematically, integrating 24t, integrating, add 1 to your index, divide by that new index. So I've got 12t squared plus some constant. Now, this substitute the initial condition is really saying, and find the value of your constant. The initial condition, or the conditions we were given, is we were given that the velocity would be negative 12 when the time was 0. At this stage, I'm not using this, that displacement's equal to 0. Well, that just means I don't need it for now. And you will see that I will need it in part B. So I'm not using all the information given. I'm just using parts of the information given. I'm going to solve, and I've actually called this one C1 because later in the question you'll see I've got another constant which is not the same constant as this one. So first constant, solving, very easy equation, and you get that the constant is negative 12, which enables me to complete my velocity function. Velocity is 12t squared minus 12. And that's all I had to do for A. B says integrate again to find the displacement function. So again, I have to know to do this. I have to be able to bring this to the solution. That the displacement is the integral of velocity. So just what is my velocity function? I'm taking that from here. And I'm going to integrate, add 1 to the index, divide by the new index, add 1 to the index, and we'll have a different constant this time. And again, we have to find the value of that constant. So this time, my connection is between displacement and time. What do I know? I know that when time is 0, displacement was also 0. That was given back here. So now I am getting to use that information that was given. And I'm going to sub 0 into that spot. So you can offset that. Given that x is 0 when t is 0, because that was given, solve for my second constant. And it works out that that constant is actually a 0. So I've got now that the displacement function, or displacement, can be found by taking 4 times time cubed minus 12 times the time. C, find when the particle is stationary and find the displacement then. If you did spend the time back at the beginning getting an understanding about what was going on from the information that was given in the beginning, you would be not surprised that you would get this part C. We'd already said that you can expect, given what we knew at the beginning, there would be a time when the particle stopped, became stationary, and I was wondering when that would happen, and I'll be surprised if displacement is not a negative. It'll mean either I've made a mathematical error, or my initial understanding of what was going on was wrong. Let's see. So find when the particle is stationary. When, if you're finding when, you're finding t. Particle is stationary. Particle is stationary. How do I interpret that mathematically? If it's stationary, it's stopped, it's not moving, its velocity is naught. So knowing that the velocity has to be naught, I want an equation about velocity and time. So my equation about velocity and time is this one. So I take that equation, v is equal to 12t squared minus t. And I know that that velocity has to be 0, is 12t squared minus t. It is a quadratic. Yeah, let's say 0 is equal to, take out your 12, you'll have t squared minus 1. Divide both sides by 12, or to get this, 12 is never going to equal naught. So how does t squared minus 1 equal naught? Well, you can do it two ways. You can see that as the difference of two squares, or you can be really careful, and when you take the square root, consider your plus minus. So you can see the only way you can get a 0 is if t is 1 or if t is minus 1. T is minus 1 doesn't make any sense. We'd never talk about a negative time. So in this case, we only have to consider one time value, and after 1 second, the particle must have stopped. So this is when we're going to find what its displacement actually is. What is displacement? Well, we got from here our expression for displacement, and that is displacement is 4 times your time cubed, 1 cubed, minus 12 times 1. So our displacement is 4 minus 12, which is minus 8. Now, confirm, and they're centimetres. So at a location of 8 centimetres to the left, on the negative side of the origin, the particle stopped. Confirms my initial understanding of what was going on was correct. I'll have to pause the video. In D, it says find when the particle returns to the origin. So find t when returns to the origin. That's telling me about the displacement, and find the acceleration. And so I'm wanting a connection between displacement and time. That's again, yeah, displacement and time. So I want displacement as naught. I'm going to solve that equation. Just factorising. T is equal to, we only need to consider the positive square root, and the question also asks for the acceleration. So you'll sub your root 3 back into your acceleration equation, which is over here, was given in the beginning. So it's just 24 root 3 centimetres per second squared. Sorry for the rush at the end, and ask me any questions in class if I've gone through any of that too quickly.